This video is going to talk about the effects of radiation. So what happens when you are exposed to these alpha particles, beta particles, and gamma radiation. This here is our little graphic that you're going to see multiple times. If it helps you, I'd copy it down. This here is our lowercase alpha. This here is our lowercase beta. This here is our gamma. So let's talk about alpha particles first. Alpha particles are going to be moving fast, but if you think about it, compared to a beta particle, it's a lot bigger. This here is the size of one electron. This is the size of a helium nucleus, or 2 protons and 2 neutrons. So gamma particles aren't going to be able to fit through as much stuff as, say, alpha particles aren't going to be able to fit through as much stuff as, say, the beta particle or the gamma radiation. The alpha particle will be able to penetrate a sheet of paper um, if it's a thin piece of paper, but really like tissue paper or something like that. But really most of the case, paper will stop it. So paper is your kind of line where you draw, okay, some papers it goes through, some papers it doesn't. So paper pretty much stops your alpha particle. Anything thinner than the paper is going to let it go through. Um, but you can use just simple paper to protect you from those. If you are exposed to alpha particles, it's probably just going to cause burns to your skin. It will be irritating, but nothing that you can't really just heal from. You do want to make a habit of not being exposed to these things. They are very dangerous to you. Next is our beta particle, which again is going to be a lot smaller than our helium nucleus alpha particle. Beta particles are going to move faster due to the fact that they have less mass, and therefore the energy that is expelled off isn't going to be used to keep propelling that mass. So our beta particle will be able to fit through your paper, but in most cases a sheet of aluminum will be able to stop it, this aluminum being about 5 millimeters thick. If it does get to your body, because you are not aluminum, it will damage the cells that it hits. I mean, you can think of this thing as just colliding with the cells at extremely high speed. It will burst them, it will damage them. You're not going to have a good time if you are constantly being exposed to these things. Our last one is the effects of gamma radiation, and these are actually the biggest concern we have when it comes to radioactive decay, is these gamma rays. These gamma rays are traveling really fast, and they have very short wavelengths compared to other forms of light. In fact, they are the shortest of the forms of light that we know of right now. And these gamma rays will penetrate paper, will penetrate aluminum, and even go through a thick block of lead. You can think that x-rays normally get blocked by lead, because when you get an x-ray, your doctor or physician will actually put a shield on you. Even if you go to the dentist to get x-rays of your teeth, they put a heavy lead shield on your chest to prevent x-rays damaging you. Well, gamma rays are even more powerful than x-rays, because they will go through and they will disrupt it. They will cause intense damage to your cells as well.